Hi there, good afternoon. Looking at the high altitude balloon preparation here, I have two parts that I've 3D printed that I'm going to send up uh, with the balloon. And the first one is this cube, and it's approximately, because it's 3D printed, half inch by half inch by 3/4 of an inch long. It has a hole in the middle that's 3/8 wide by 1/4 of an inch tall that goes through the object. So this one can get cable tied to the outside of the U-line foam insulated box. And the second one is like a miniature debit card. It's 1/10 of an inch thick. It's an inch in this. It's an inch in Y, and it's a inch and a half in the X here. So these will both get sent on the outside to see if there's some change that happens that it doesn't recover from. Thinking like if there's a camera, something that we want to put on the outside. Is 3D printed material? Is it an applicable use to do that? Can we put sensors held in place by a 3D printed object? I don't know. I've never sent anything to near space, so I kind of feel like it fit really well with the STS employ the EDP principles to solve an engineering problem. So. Does it change a lot? Is it going to affect the sensors if it changes in temperature on its transition from 1,000 feet above sea level to 90,000 feet of altitude? So, kind of looking at engineering toolbox, they have a website here that has all these different thermal expansion coefficients for some common materials. So we have ABS, and it lists at 72 to 108, and what that actually means is that it's 0.00090 because it's 90 times 10 to the negative sixth. So it's a really small number, but that gives us a formula at the bottom here. It says example linear expansion, so we click on that, and what we have is we have a formula that looks like this, where we don't know our change, or we're going to calculate our change. We have our physical size, what's the coefficient, what's the temperature that is at max altitude, or our first recording, and what is the starting recording. So we plug that in, and we have our 0.753, which comes from the cube is 0.753 inches in length in the X. And then we have our coefficient. We have negative 56, which if you Google what is the temperature at 90,000 feet, it's negative 56. So for this example, we could try that. We have 50 degrees at launching. So if we plug that in, we get negative 0.00718. So it's gonna shrink. And so the question is, does that number, that 0.007, does the part return back, and is it 0.7458, or has it gotten to a smaller size that would show that it has changed permanently? It hasn't rebounded back to its original size. So, or does it come back and it's in two pieces, or it doesn't exist because it became brittle and fell apart? So that's kind of the idea here. So there's a calculator that's built in, and it also matches the 0.7458 that we found. So I'll put that in my engineering notebook. So if it's going to get negative 56 degrees, and it's 50 degrees on launch day, because that's what Omaha weather.com says for Friday, April 20th, if that's actually what the temperature is, we'll see. Does it come down to be that small? Is that within enough tolerance for a part that I want to send up for future experiments? So hopefully that helps with my preparation part of the high altitude balloon experiment. Thanks.